So yeah, what this talk will be about, it's basically, in simple terms, kind of stuff around how if you have a lot of data and a big knowledge base, you have a way of retrieving the relevant items from that knowledge base. And especially when this is not just text, but when you have metadata involved, so not only images, but stuff like locations, categories. For example, when I say categories in e-commerce sense, let's say, what I mean is having like a whole tree-based structure, which is like men's shoes, leather, whatever. There is a data structure in itself there that sometimes you want to keep in mind. And I will probably start. I don't know how late they are or whether it's behind schedule or not. But yeah. So I wanted to do this talk and kind of talk to you about how you can use this vibe coding tools that are available in order to build a search and recommendation system that's quite intuitive and easy to understand, but also explain to you why you would use Superlink, which is the company where I come from, because it enables you to do search and retrieval differently in a way where you can have this accurate retrieval in the first pass and get your relevant items without doing any boosting, filtering, post-processing, re-ranking. So these are all steps that usually people do in the process of building search and recommendation systems. And the idea here is that if you do your job well enough in the beginning, when you do the embedding generation, when you set everything up, you will not have to solve all of these things later on. So this is me. My name is Filip. You can add me on LinkedIn and look at all of the stuff I talk about. So this is all open source. You don't have to pay anything. You can do it on your own, build it at home. So add me on LinkedIn, talk to me, ask me stuff about Superlink or in general. Happy to talk about AI. And I am an ML engineer, and I've been an ML engineer, but what I do now is also I work in developer relations, which means I talk to developers at events, I hold talks, I do content creation around AI, which helps people understand AI, work with AI, do different things, mostly concentrated around search, retrieval, and ranking, but also AI more in general. So the motivation for what I'm talking about today is around the expectations of people in this new LLM AI age. So nowadays, when you go to a retail website, whichever one, if you say something very complex, so also even OpenAI agrees with this, that kind of the shopping experiences will change a lot and the future will look different. If you write something like this in today's websites or search systems and whatnot, most likely you will not get the relevant items. So if you say popular family-friendly hotels, most places will have a keyword search where it looks so family-friendly hotels. And then if you say not for children or not suitable for children, it wouldn't detect that nuanced difference between the keywords. So this kind of queries are a problem for a lot of systems. So feel free to come in and join in. That's a good sign usually if it piqued your interest. But yeah, exactly, that's where we are. When doing something like this, popularity as a word is not a binary filter. So what that means is that you cannot define popularity as something that is popular or isn't popular. There is a level of like higher resolution here, like a sigmoid function, which is like some things are a bit less popular, some things are a bit more popular. And you cannot say, unless you hard code some filter, oh, this is popular, this is not popular. If you do this cutoff, you're losing on this resolution, you're losing potential data in this place or hotel that we're looking at. And this happens with numbers, this happens with locations, this happens with things like negations and family-friendly, not family-friendly, and so on. And what the normal solution is that we disagree with is that you can just use a text embedding model. So you take the best one, you go to OpenAI and take the best text embedding model, or Gemini, whatever, and you chuck everything into a text embedding model. You get this embeddings, and then they map out all of your terms in this big vector space, and then you can do search, and you're like, cool, I've used AI to solve my search problem. However, in practice, that doesn't work because something like this happens. So this is the most simple example that we've tested, and you can try right now with any state-of-the-art embedding model that's out there. If you take the embeddings of numbers and see what the vector representation is of the number 10, let's say, and if you see, okay, now I will embed number 10 and I will embed number 11, and then you do cosine similarity, you will see that number 10 is not the closest to number 11. So the embeddings do not represent the numbers in a way you want numbers to represent it in. Because the way LLMs work and these embedding models, they keep into account kind of the frequency of appearance of certain numbers. So you have the problem of not being able to have representative embeddings. And this is the case just with numbers. So this example is just with numbers, but it extends to all sorts of data types. So not just numbers. This is just the simplest example that you can try right now. And this is the extended version of this. So what I mentioned, metadata filter. So if you take stuff like popularity or like recent or near, cheap, these words are in natural language, they don't mean things that are binary. They don't mean stuff like popular, unpopular, recent, and not recent. You need a smooth function here to represent what the recency means, because there is always something more recent, something less recent, something more popular, something less popular. And if you just do a filter, like most search systems do, you're losing out on the potential data, potential nuance, potential information. If you say, okay, places near Canary Wharf, and you've set your filter to 1 kilometer, and the hotel that's maybe the perfect match for you is 1 kilometer and 1 meter away, you've lost it out totally just because you set the filter wrong. And if you do this for 5 different things and for many different terms, it turns out that your whole retrieval process is broken from the get-go. So that's why we say we want to build a vector-based system where once you do this retrieval, you can always have a result, no matter how far or close it is to the source, this hotel you're looking for, you will always have a result just because you do approximate nearest neighbor search with vectors and so on, which means you map them out in this big vector space and you can always find the distance between 2 points. And in a way, what Superlink helps with is doing this vector-based search system that performs like almost as if you have a fine-tuned model on your specific problem. And that's very powerful, and that's why I'll be teaching you how to vibe code your recommendation system with Superlink. And as I said, this happens in industry a lot more, so this problem is more pronounced. It's not just numbers that don't work, but you have structured, unstructured data, different data sources, databases, data lakes, SharePoint, Microsoft, PDFs written by hand. All of that needs to be inputted together, and you need to be able to extract, collect this data, and then search through it. So it's multimodal in nature, and it's not just, okay, I will have a text query and everything will work perfectly, but you end up having to build like a multimodal, natural language-based hybrid search system with boosting, filtering, and re-ranking, which is not simple at all, very brittle, very error-prone. So what we want to do is that photo there with the burning fire, to replace that whole pipeline with one very accurate retrieval step. And then you have everything sorted out from the start. And that technique that does this, we call it mixture of encoders. So this is basically how this is done. So instead of chucking everything into a text encoder, you have smaller encoders or embedding models or whatever you want to call them. And they embed a specific part of your data, both the query and the data. So as you can see here, there is a number encoder which generates this small embedding that has the information about the numbers. Then you have something like data encoder, category, image encoder, semantic encoder, etc., etc. So these are all specific encoders that you can use. You can also chuck in any open source model that you want for images, for text, and so on. And then you end up with a vector that's very long and has all of these different subvectors within it. So we normalize and concatenate and have this long vector that has a subvector representing your numbers, a subvector representing your images, a subvector representing your category, a subvector representing all your data types and modalities. And this works because once you normalize this and you chuck this into a vector embedding, you can do vector search and approximate nearest neighbor search and use any vector space, any vector database to actually represent this. So then when you have this query that I mentioned earlier, you can represent, because it's vector search, so the way vector search works is that you can always have a result. So you don't have clear hard-coded filters. You have like popular would be a numerical bias, then you have categorical bias, semantic bias, and all of these things that help you get to a point where you can do stuff like retrieving the right hotels. And if the hotel is popular in the last week, but then there's one that's very relevant to your query, has the good price, is not suitable for children, has the right amenities, whatever, but it was popular 8 days ago, not in the last week, you will still get that result and it will be there, just not, it won't be cut off as if it would be in a normal scenario. So you're able to divide and conquer and have different encoders for different data types. And this is how this looks in the real world. Like you have categories, pricing, availability, locations. So this is a real scenario of an item in e-commerce where you have different ratings for it. So if you say, oh, I want items with ratings above 3.5, what if, again, the item is somewhere between 3.4 and 3.6? You might miss out on a relevant item. So basically what Superlink does is there is a specific encoder for description, for category, for price that is optimized for each data modality. And then you can search using vector search and do all of this metadata search without having to like filter through everything and just use this vector search approach. In a more technical way, this is how it looks, but given my short survey of the crowd, I will not dive deeper into this, but basically there is also a smarter way of doing this. So this is, we have an open source Python framework that you can use, so like a repo that you go in it and you can test this out. But basically there is a cloud component that helps you scale this in production, that has a computational graph on top that helps you scale and build things with Spark and so on. So it's not just like some research project, but this works in production. We have clients who are public companies. It's also the scale part that has been thought about. And this is the idea. So each vector contains different subvectors which capture a relevant aspect of your data, as I mentioned. So this is like the visual representation of how this would work, but maybe in a more scaled result where each example would have tens of thousands even of dimensions, so not just this many. And this is maybe not something that popular in the sense that most things that evaluate similar stuff like this, like search and retrieval systems, are only text-based. So you probably haven't heard of these problems that much because most of the leaderboards and competitions are text-only or text and image. But there are no metadata-heavy benchmarks. So this is the case if you've gone into this stuff. There is like MTab, Beer, they're both leaderboards that have different structures, and I won't dive deeper into this, but basically they're all text only. And what we do is text plus metadata plus images plus all sorts of stuff. And we wanted to extend this and have a way of showing you that this works actually. And we have this article on comparing this approach of mixture of encoders with other state-of-the-art retrieval approaches that you can have a look at. And we have an open source repo. So yeah, this is totally free. Basically, the way that we charge clients is that once you go after a certain scale of vectors, you could choose to schedule a call with us and we decide on how to, we have like forward deployed engineers, and we decide how to scale this for you with our premium cloud offering. But up to a certain scale, which I think could be even around 100,000 vectors, you could totally use the open source repo and we wouldn't even know. But you can always tell me if you use Superlink. I'd be happy to know. That would be encouraged. And yeah, feel free to look at the repo. We also have other resources like the docs and the articles. These articles are like tech articles exploring these topics on how retrieval works, what we're doing better, general topics around AI, so that could be useful. And also the other resource we have is like a vector DB comparison table. So if any of you need to use a vector database at some point in your journey or whatever you're building, this is a good resource. You can see each vector database, what features they have, what they're doing bad, what they're doing correctly, and this is updated live by people from the vector databases. So this is checked and out there to help you picking a vector database, basically. And what we do is on top of vector databases. So we're not a vector database, but we work with vector databases to add this layer of retrieval and search. So we also have LangChain and Llama index integration if you're into building more RAG stuff. So we're working with the R part of RAG, the retrieval part. So you can check those out too. Very cool kind of integrations. And now my last part of this talk is, can we build something similar with all these things I've mentioned, open source, all cool and nice, but can we see this in action with a bit of prompt engineering and prompting as the context of this conference is? So I would describe how you can do this, and you can try this even now or at home. I don't mind, but this is all free and open source, so you don't have to sign up or do anything. You can just do it on your own. So what you'll need is the original Superlink repo, and you would clone this locally and open it in Cursor or Windsurf, whatever. I've chosen that platform, but obviously you can do this with Claude Code or whatever vibe coding platform you have, or IDE. And then we also have in our repo this deep wiki kind of integration where you have this Devin agent going through the repo and understanding the structure of it. And you can see here that it creates like a whole wiki page of your product or the repo. It works with public repos with, I think there is a certain threshold of stars, maybe above 1,000, and then you can look at those for free. So it shows like how we do vector space, index management, whatever in detail, and you can ask questions to it. So what I recommend in this cloned repo that you have, you ask Devin, hey, can you explain to me how to build a recommendation system for this kind of thing using Superlink and so on. Write a prompt like that and take that output and create a markdown file in your local version of the repo. And once you're there, you would go to one of our full end-to-end examples, like this hotel search and recommendation example. This is also an open source repo that you can get. So basically, this is a hotel search example, like I talked about, when you search stuff like cheap but highly rated hotels in London, no children. The stuff that matter here is that no children, usually that throws off a lot of search systems. And stuff like highly rated and cheap, again, what does that mean in numbers? You want the vector search to help you here so that you can have highly rated, maybe in one case that begins with a rating of 3.8, maybe in another it begins with a rating for 4.5, right? You don't want to have all this manual engineering of the features and testing out different keywords until you get to, for that distribution of results, what's the right number so that then I can properly represent relevant results. And you get all this on the side. You can see price weights and rating weights. So basically the model infers from the natural language query how to bias the results so that cheaper stuff pop up front and highly rated are also taken into account. So you take this repo and you do something which, this is the thing I explained with the weights. I won't dive deeper into this, but the cool thing about Superlink is that you can bias all these little sub-vectors that I mentioned. You can implement your business logic and say, okay, now it's Halloween. I want to push stuff that have spooky imagery or whatever, or some stuff specific to some holiday. And you can do that without re-ingesting everything, without a cold start problem. you can just adjust these vectors, and this is mainly just a scalar multiplication. So you multiply the subvector by a certain number, and that pops up higher. It's pretty neat. So anyway, you take, this is our docs. So you have a description of it, you have the repo, and you do git ingest, because that's a smaller repo, and this works really well. So this is a quick tool where you can get a markdown file for all of your repo, and it has the right context in it. So you copy this markdown file that this generates. It's 2,000 lines, this one. And you create another markdown file in the repo that I described previously that has the clone of the Superlink repo and the other markdown file of the deep wiki Devin kind of question that you asked. And then you can set cursor planning to tell it, hey, build me a recommendation system. I've done an example with cars. So I was like, okay, generate synthetic data about car parts, and I want to build a recommendation system that can search through stuff similar to that hotel demo. And it creates this to-do list where you have all the stuff like create the complete folder structure, define car schema, accept natural language query. So this schema and natural language query thing, there's Superlink specific stuff that we've managed to introduce to the LLM, and now it knows, okay, in order to make this similar to this recommendation system, I need to have all this stuff done. And it also asks you some stuff like, oh, do you want a Streamlit web app? Do you want like a full Next.js or whatever? Do you want just the backend or an API? Because Superlink generates a REST API, so you can have this. You can use this for your email campaign if you want. It doesn't have to be a website or search. You can use it with your internal data in any way you want. And then you get something like this. So this is the screenshot from Cursor, where you can see this is the README file, and it was able to have query examples that are very similar to the hotel one, obviously, but it has like this Toyota Camry car with year, price, mileage, ID, then all of these relevant files that you can see, like the TOML files and a bit of like notebooks to introduce the topic, but also this NLQ query index, all of the stuff that are Superlink native. So this index is created, you can see in that hotel example, generating this mixture of encoders, and then the end result is like this embedding. So you can try this and it will work. It might need some adjustments, but it's pretty relevant. And this is the summary of it, where you can see there's the car schema definition. So in Superlink, when you build this stuff, you set up a schema in the beginning, like, okay, for my hotels or for the data that I have or the metadata that I have, I need the brand, the model, the images, the car part ID, whatever metadata you have, you include that there. And then that's embedded with all the specific models that you want to use. And then all of the steps are done. And yeah, that's how you would do this. I'd be curious to see how this goes. Also, I don't have this in the slides, but this is like an extra thing. If you build something with Superlink and it works, we offer a reward that's like up to $500 in either it will be a gift card or like cash. So you can message me on LinkedIn. If you do this, we'll probably write an article around it and give you $500. So it's a cool deal. And yeah, just send us the repo or whatever. We've done this like a lot in hackathons and so on. So I just felt like this could be interesting for you guys to try. Whether it's vibe coded or not, I think it's more about whether it works, and it's an interesting idea. So feel free. And as I said, this works also in production. So this is the more businessy side of things. I won't dive deeper into it, but you can ask me and catch me at the break, and we can talk about it more. But this is the visual of what happens when you use something like this, like mixture of encoders versus not using that. So there is that without Superlinked, where you search at, this is like a popular retail website, where you search sparkly dress for Christmas under 100. You get that, which is not relevant at all. And in one of our demos, which is basically an e-commerce data demo, when you search sparkly dress for Christmas under $100, you get that, which is relevant. And you can also bias the results and do all these cool things. And you don't need to do re-ranking or any filtering or any 10-step process. So it's just that query and you get the results because you've set this up properly from the beginning. So thank you. And yeah, any questions, discussions, happy to take questions now. Also happy for you to catch me at the break. But yeah, there's one question there, the furthest back. And I'll go to my starting slide just so you can add me on LinkedIn. Yeah. I don't know if you'll get the slides, but...
Thank you, Filip. That was really good, especially for a technical presentation. It went in. How does this all link with, I forget the terms, with the optimization, answer engine optimization and generative engine optimization? So you've got something like this and then getting it out onto ChatGPT for commerce. Do you do that? Is that something that is on the radar?
So this would work with like your own enterprise data. So imagine you're like a company. You wouldn't necessarily get all your traffic from ChatGPT or from the generative engines, right? So you'd still want to have a good experience on your website, on your internal docs, on your internal knowledge base, on your whatever internal systems, right? So this is more using your own company's data to build this solution in-house. So it's not like an alternative to Perplexity or ChatGPT, but it's something that you would use to build internally in your own company, if that was the question.
All right, another one.
I was going to say it's not necessarily a question. And I don't know if there was an egg that we should find in your slides.
Okay.
But I really like that you have witches in your vectors that do your ranking for you. Because on one of your slides, you've got witches.
That's possible.
Instead of witch, as in W-H-I-C-H, but you've got the other
which
witches.
One?
I couldn't remember which slide it was.
No,
there we are. There, you just went past it. Go back again. Keep going. Go again. Go back again. And again. Maybe go back. Go back. Because I just literally just saw it. You have witch.
That's cool.
Keep going.
No, this looks like magic, so that's actually the point.
Yeah, so I thought that was quite cool that you have witches in there and that they help you with your vectors and your ranking. Maybe go forward one more.
That's cool.
Helped with the little book down at the front. That would be great.
No, yeah, that's cool. But this wasn't intentional, although I've done this with... But yeah, that's like I've done this more with imagery rather than in the past, rather than with words. But yeah, that's a cool way of like also the semantic similarity between which and which. That's an interesting added element here. But yeah.
I'm glad this guy brought up magic, actually, because a lot of people... And as a machine learning engineer, this is where I'm going with the question. I'll try and make it as simple as possible. But a lot of people think AI models are magic. Oh, you found it. Witches. Go back one. See if we can find it.
Which one? Small?
Just go back. Right, now go the other direction. One more. Stop. There.
Yes. Yeah. Nice. Okay. Exactly. Let's stay on this one.
Stay on this one. So, yeah, a lot of people think that vector databases are magic, but an AI model is just a database, isn't it? But a compressed, like a PNG is a compressed form of an image. Is that, are we on the same page?
To an extent, yeah.
To an extent, yeah. Because this is what I don't understand. Every time I ask someone that question, they say to a certain extent, right?
Yeah.
And I'm trying to work out, I'm a software engineer, so I'm trying to work out how the retrieval process itself works. Is that done by Python, which is actually outside the dumb model, just static model, like a database? If I download an LLM onto my phone, which I have done, and I'm using like an app, an offline app to actually interface with it, is the retrieval being done within the actual app on my phone, or is that sort of being done within that 3 GB model that I've downloaded myself? That 3 GB model I've downloaded is just a vector database, but then the retrieval process is actually taking my query and making sense of it in a way that the right vectors can be found from the database.
Yeah. So I guess we can discuss this in more detail after, because there are a lot of like steps
It's quite
here.
heavy questions.
But in simple terms, it's not done in the model itself, but it's done with stuff around it. The way it works is using linear algebra in the simplest terms. So basically, the LLM, the output of the LLM, it's encoded in a certain way. So it uses this vector embeddings, which are kind of representations of data. And these representations of data, because they're vectors, you can do different mathematical operations with them. So that means that you can do linear algebra, which means you can do cosine similarity, which means that if you have used that LLM that you downloaded to generate this vector, and then you use that same LLM to generate another vector, you can do some calculations between these two. And retrieval in itself is doing this calculation where you calculate how similar these generated data representations are.
So the app, like if I download Quen or Llama, for example, one of those models, the app that's using it, I'm trying to remember the name of the app that I've got, say Pocket Pal, for example.
I have no idea what Pocket Pal is.
Okay. So it's just an app which allows you to download like some Quen models, get them on my phone. So that app itself is putting my query into the database, which it loads into memory, Quen model, creating something, and then, yeah.
So there is the slight difference between like LLMs and embedding models. So not every LLM is an embedding model, but the embedding generation is usually one step in these LLMs. So, for example, ChatGPT, when you talk to ChatGPT, this is not necessarily doing search and retrieval or doing embeddings in the same way.
Okay.
But when you use Quen, Quen has an embedding model, so it can just generate this vector representations of the data.
Can I ask one more question? Is
Yeah,
that all right?
yeah, of course, it's open.
I'll take it a bit more high level.
Yeah.
So I was reading a post today about, and you mentioned it as well, about how LLMs are not very good at doing numbers. And if you ask ChatGPT, some of the older models especially, give me a random number between 0 and 25, it will consistently say 17, right? Because it's using curve fitting and predictions for getting that number, and it's not actually doing any maths. So some of them, number 5, G5, is actually better at doing that. And I'm wondering whether they take your query, do a whole bunch of like post-processing on it without using any AI models, or maybe just certain smaller ones. And are they trying to determine whether your question is better for a language model, which is a part of their backend system, or like an image model, and then it will give you an image, or a number model? And my question basically is, how easy is it to mix language queries and number queries? If you want to have a mathematical operation, is it best to ask only a number-based mathematical question and not mix it in with something with a lot of text in it? And
So that's the beauty of what I mentioned here. It's basically the same if you embed the things in the right way. So this vector representations of data that the model generates, that's the only thing that your model see. They don't know whether that was a number, an image, a video, an image and text, and so on. You just have those. So it doesn't matter what you use, but what we're doing here, exactly as you pointed out, is using this specific model so that then when you get that representation of the data, you can actually do this similarity operations properly and have the relevant context so that numbers are represented nicely, images are represented nicely, and so on. It's not just all mixed up. And just to answer the initial part of your question, with LLMs, what they do is, with these questions that they've corrected themselves on, usually it's not something that they do live. So live, when you talk to ChatGPT, they have a routing mechanism nowadays to select like whether it would use a reasoning model, whether it would do deep thinking based on your query. But this stuff they usually do post-training. So they do like supervised fine-tuning and like group policy optimization specific to this problematic query. So they've done that before you even got the chance to access the model, but they do some routing live when you talk to it. But it's more of a post-training function that most labs do nowadays.